Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean, the simplest cloud platform out there. And we're excited to share they now offer dedicated virtual droplets. And unlike standard droplets, which use shared virtual CPU threads, their two performance plans, general purpose and CPU optimized, they have dedicated virtual CPU threads. This translates to higher performance and increased consistency during CPU intensive processes. So if you have build boxes, CI/CD, video encoding, machine learning, ad serving, game servers, databases, batch processing, data mining, application servers, or active front-end web servers that need to be full duty CPU all day, every day, then check out DigitalOcean's dedicated virtual CPU droplets. Pricing is very competitive, starting at $40 a month. Learn more and get started for free with a $100 credit at do.co/changelog. Again, do.co/changelog. Welcome to Practical AI, a weekly podcast about making artificial intelligence practical, productive, and accessible to everyone. This is where conversations around AI, machine learning, and data science happen. Join the community and Slack with us around various topics of the show at changelog.com/community. Follow us on Twitter, we're at Practical AI FM. And now onto the show.
Welcome to Practical AI. I'm Daniel Whitenack, a data scientist with SIL International, and I'm here with my co-host, Chris Benson, who is a principal AI strategist at Lockheed Martin. How you doing, Chris?
Doing great. How's it going, Daniel?
It's going really good. I spent some vacation time doing a little bit of backpacking in Minnesota, so just about the opposite from my day-to-day life sitting in front of my computer screen. So it was a really nice disconnected time. So happy to have that time. Do you have any good times over Labor Day?
Yeah, I had a good time with the family over Labor Day. We went to a local lake in the Atlanta area and did a little kind of a beach thing, which was nice. And I, too, am looking forward to a couple of weeks of vacation coming up. I'll be in the UK. My wife is British, so we spend a lot of time over there. And other than that, lots and lots of business travel, conferences, things like that. Yeah,
definitely. You're keeping busy for sure. Well, today we have Sherol Chen on the show. She is an ML developer at Google. I met her recently over the summer. She's doing some really awesome things and has done some really quite a bit of different things while she's been at Google. But really happy to have her on the show today to talk about some of the things that she's doing with Google Cloud and some other AI things. So welcome, Sherol.
Hey, nice to meet you.
Yeah. Well, could you just give us maybe just a little bit of background about, how you got into computers and eventually AI and programming and ended up at Google and doing machine learning and all of these things?
Yeah, of course. So currently I work at Google, like you said, and my primary area of focus is auto machine learning, which has been this up and coming practice in machine learning, where you're basically given the labeled data, and at the end of it, you get predictive model without having to really do very much machine learning in the process. And what brought me here, I guess, like that story starts with my first computer, which I would actually say was the Nintendo, which kind of dates me, I guess.
Nice.
Yeah.
Nice, like the original Nintendo.
The original Nintendo was like my first, gateway into technology. And I just remember I have a lot of memories of just playing, hours upon hours of games and being captivated by these virtual worlds, these very pixelated virtual worlds. And, just like, not only was it just, wondering how it was possible that we could have the input, output, all that feedback coming out of my TV, but, thinking and dreaming of how I could make it better. And so naturally, I went to a high school that happened to have, computer science. And I remember asking, what is computer science? I was in a classroom eventually of 4 or 5 students that, happened to have a particular interest. It wasn't like a very widely popular subject area. Then, of course, naturally you go to college, and I think I'd forgotten that I loved video games at some point, or that was kind of my motivator. And so at some point, I think it was I was late to playing this game, but Final Fantasy VII
Nice.
really got me back into thinking about these worlds and the stories that they told. So then I signed up for some summer research, and I did a research project looking at artificial intelligence and storytelling, which then led me to UC Santa Cruz, where I studied under Dr. Michael Matthias. He was a leading expert in interactive intelligent dramas, he would call them. So they're basically these, he created this game called Facade, which is this very lifelike, reactive, natural language driven interaction or game within this story of this couple that you would go visit them and talk to them. And at the time it was that was 10 years ago. It was state of the art, there hadn't been anything like that before. And that really, really motivated me to go and pursue studies under him. So I went to do grad school there. And while I was in grad school, I thought I would be an academic for the rest of my life. I thought I wanted to be a professor. And in some ways I still do want to be a professor, but I was in Silicon Valley, and I took an internship with Google because somebody asked me why not? And it totally changed the way I saw the world. I thought of impact in a totally different way. And so I started at Google, like you said, at Google, I did a couple different roles. So I was at YouTube, working on YouTube search as a software engineer, really looking at search algorithms and the ways that little changes here and there could impact how people use the product. Then I wanted to be more publicly engaged. So I was doing developer advocacy at Google Cloud, working with the machine learning and AI tools. And that's really kind of where that was also around the time the ML boom was happening. One of the big oh my gosh, look at all this progress, look at all of the abilities that weren't possible before, enabled with machine learning. And that was probably 2016. Yeah, it was around 2016. And then I ended up doing a rotation with Google Brain, which is one of the premier groups working in AI today, working on Project Magenta, which does music and machine learning creativity. And then as I'm digging deeper into these products, that led me to AutoML, which I explained at the beginning. But yeah, that's basically my journey from video games to working in ML at Google.
That's amazing. Yeah, I'm interested in one of the things you said was it kind of, going to Google and experiencing that kind of reset your ideas about impact. Do you mean like in academia you can have an impact because you can research new things and kind of release them into the world in some sense? Is that the kind of impact you're thinking of, or how do you view impact these days in terms of the AI work that Google's doing?
Yeah, I mean, I think you're right in that what we do in academia is that we write papers, and these papers hopefully are cited by future papers, and that people receive them well, and it helps continue to advance the state of the art. And to me, that was is very romanticized in my mind. When I went to undergrad, I thought, this is where everyone's just talking about ideas and challenging one another to do better. And I found that in grad school more so. But then it was kind of all I knew, right? It's when you're looking up to your professors, you're oh, I'm going to become that someday. You think, in addition to all that, think about how you're going to be a teacher, and how you're going to mentor people, and how you're going to grow a group that way. And so, I'm almost embarrassed to tell this story, but I honestly didn't know, I didn't go into computer science thinking I'm going to be a software engineer. I'm going to, I wasn't influenenced by the .com stuff. I really had no idea. I wanted to make video games. I would call up Nintendo's hotline. I think it's 1-800, I had it memorized, 255-3700. I don't even know if that's right, but it was something like that. And I would ask them how do I make video games? That was how detached I was to how kind of the non-academic world functioned. So when I went to Google, I was, really excited because it was a whole new world that I didn't understand a whole lot about. One of the questions they asked me was, this is really embarrassing. How many users did I think YouTube had? And I was like, okay, like what's a big number? For me, in research, like having 100 users was like, that was like a lot of users, like too many users. I remember the statistician telling me like 100 users, that's like too much data. Like you collected too much.
Yeah, I don't think what I coded in grad school ever had 100 users for sure.
Yeah. So the number I gave, and sometimes I'll even like multiply my guess by a factor of 10 because it's so embarrassing. I was like, oh, like 10,000. Like I didn't even think about it. I said 10,000, and the manager like laughed and then said, never mind. And then moved on.
There's at least 10,000.
Yeah.
That's a good story.
Yeah. No, this was like just, that was like how new I was to it. That's how little I knew about like the product side of things, like the real world applications. Yeah. And sometimes when I tell the story, I'll say 100,000 because it's a little bit like, okay, like,
yeah,
I can see that. But yeah, no, I literally said 10,000. So
yeah. So like the scale of the impact of YouTube and like anything you would integrate in YouTube, including like whatever it is, like, whether it's AI related or not, is going to have an impact on a scale that's just totally outside or just totally different than what it is in academia, basically.
Absolutely, yeah.
So I gotta, before I ask a question, I'm actually gonna throw back all the way to the beginning when you were talking about your childhood in high school, and I think I might be slightly older than you because my first computer game was the original Atari system.
Wow, yeah.
And then when I learned how to when in high school they were still teaching typing on typewriters.
Oh,
nice.
That was just coming to an end there. I know. So, and we didn't have a computer in the school at the time. So I'm slightly older than you, but just barely.
Yeah. I work with a guy. I just think this is cool. I work with a guy who met his wife messaging back and forth on the, I think it was the University of Michigan like mainframe.
Wow.
So it was like there was no internet, right? So they like let students access like the University of Michigan mainframe, and they were like two of the students messaging on there, and they eventually talked and got married. I thought that was pretty great.
That might be the only mainframe romance story I've ever heard of in my life. So, okay. So I want to actually get a little clarification because, we are all always hearing about everything AI from Google, and there's all these different things: Google Brain, Magenta, TensorFlow, Google AI, Google Cloud, you name it. And so like how do these different parts of Google that work in AI areas relate to each other? And, are some of those the same as Google Brain and Google AI the same or not? And how does TensorFlow, as a tool fit into that ecosystem? And, can you kind of just give us a sense of where all these pieces of AI fit in at Google and how they relate?
Yeah, I would say that's a really good question. And I definitely have a pretty good insight having worked with a lot of these teams. So like any big company, there's the research side and there's the product side, right? And so when if you're looking to work in technology and you want to be a research scientist, then you're looking at like being the leading expert in your area. So you're good at doing image recognition and you have all these publications. If you're looking to be like on the product side, oftentimes they're looking for people who are like straight up builders, so engineers. They're looking at people who have business sense. They're looking at people who understand users, things like that. So they're like, in some ways their objectives are very different. One is looking at being published at NeurIPS or iClear, these top machine learning conferences, and some are looking. And on the other side of things, you're looking at people who want to, create a tool that has a lot of users. So at Google, it's a big company, like close to 100,000 employees. That's in the ballpark, I think. And it's all over the world, right? And so a lot of these projects are really it's really kind of an opportunity for people to see, what really sticks, what's actually going to show traction. So you see a lot of like organic emergence of different applications of technology, whether it's VR, AR, whether it's like, home systems like the Google Assistant, whether it is something like AI and ML. So like, what is the landscape? So like, I've heard people say like, you don't want the outside facing representation of your, of what you do to look like your organizational chart. So you don't want the team structure to be directly reflecting of like what it is that you're providing for people in the, in the public to use and to see and to experience. I would say that the way that they're shaping that, and a lot of this is like, I think, just being good storytellers or being good marketers to kind of put the tools in places where people who need them will be able to get them the easiest. So we have like, Google Cloud, right? That's where they're moving towards providing business solutions. They're providing enterprise technologies, things like that. So things that will help your business. Then there's what we call Google AI. A lot of Google AI, within Google, it's called research and machine intelligence. It's basically a lot of the the less looking at how many users we have, but more looking at is the work that's coming out of here relevant to the state of the art or like advancing the state of the art. And so those are kind of two of the bigger organizations that dissect even further. But then outside of that, there's like one more group, which is, I would say, like more of a collection of groups where you have like Google Assistant, Google Photos. A lot of these Google products use machine learning and AI to create better features, to create a better user experiences and things like that. So Google Cloud, I think, is pretty straightforward. If you go to the cloud website, you can kind of look at all the different offerings and things like that. I think Google Cloud AI and like Google Research is probably where it's kind of like, okay, where does TensorFlow fit and where's the AI side of things? So I could talk about it from, I would say it was Google I/O 2017. And that was when we moved to being an AI first company.
Yep, I remember. Like
Sundar was like AI first. I had just joined Google Brain at that time. And we were in a building that was like, Google's based in Mountain View. We have the Googleplex. Like it was in like, the main area, but not in the Googleplex, which is like a set of 40, 41, 42, 43, 4 buildings. And so Google, like a lot of the, Google Brain team, it was actually like across the street, right? So I joined, Sundar announces we're like AI first, and all of a sudden they're getting moved to the center of campus. And so I remember my desk was like maybe like 30 feet away from like Sundar's desk. Because of that move. And like, of course, I never really saw Sundar, and there was like a wall that separated us and you couldn't badge into that side of the building. So like, I think I'm just like looking at like the blueprints of the building. I was kind of like, oh, like, I'm like pretty close to, we're probably breathing the same air or something. But I didn't get to see. Anyways, that's just to kind of give you a sense of like topologically, like how the feel of it is, right? So TensorFlow, right? TensorFlow is like, basically it dwells, it lives, it's like being developed and improved within the Google Brain team. Google Brain team was at the time run by this superstar engineer, Jeff Dean, that, he's a celebrity inside and outside of Google. I believe like, Andrew Ng and some other people also were responsible for starting this like, Google Brain effort. And when we became AI first, it kind of got moved into, a more central location physically, but also as far as focus goes. So then Brain isn't the only thing in cloud AI though, right? Because we have groups like Machine Perception and Descartes, which, do you guys know Ray Kurzweil?
Yes, absolutely. Yeah, legend.
Okay, absolutely. Yeah, okay, you guys would. So like Ray Kurzweil has a team, right? And that team isn't a part of Brain, but he's also doing incredible work. So one of my favorite works that came out of Ray Kurzweil's group is the Talk to Books. And so, Ray Kurzweil has these like, amazing, fantastical, aspirations for technology. And so his thought is like, what if you needed to know something in a book? Like, what if you could just ask the book and say, hey, book, tell me, what's the meaning of life? And the book can just kind of spit out an answer. And so like, that was the kind of like every research lead would like kind of bring in their own flavor.
You know, ironically, that's kind of how the rest of us think about just Google search in a lot of ways, you know, as hey, we're just going to go and find out what the answer is. So
yeah,
it's just funny to hear it coming out of your mouth there. So.
No, totally. And it's like, and so like in a team like that, like they're thinking, you know, what is the next evolution of search? Right now, it's just, it's been kind of like this like keyword, like pattern matching where you look for the exact pattern of characters that you've typed in. But what if there was more of like a semantic reasoning behind, you know, search and results that arise from those queries? So like when you talk to your Google Assistant, you have the ability to it's kind of trying to reason more about your intent behind what you're trying to look for. And so they've created this idea of like, you know, rather than keyword search, what about like semantic search? And they created this game. It's called Semantris, where you have like a list of objects, and then you're trying to like semantically match the meanings, and you can knock out different words if you can get like a direct match, or there's like a, you know, 1 degree separation between meanings.
Oh, cool.
So anyways, anecdotally, that's like something that I found really, really delightful. But okay, so then Google Brain, run by Jeff Dean, and Jeff Dean now, like, you know, JG was originally the man in charge for research, but he has left, and Jeff Dean now is running RMI and doing a lot of the research leadership. Google Brain, though, at the time and now focuses really on like, you know, how machine learning can make the world better. And so there's a huge like medical side of it, right? So there are a lot of people looking at, you know, medical advancements and medical use cases for machine learning. There's, you know, Project Magenta, which is under kind of the generative models group, where they're looking at how we can generate not only just music and art, but text. And one of the cool use cases of that is generating Wikipedia pages, because you do have a large, well-curated data set from Wikipedia. And so how can you use that to generate text in intuitive ways? And yeah, robotics is another group. So then there's all these different topics, use cases. And I think the reason why Cloud AI came about was that, as you can tell, it's kind of there's a lot going on under the hood, and Cloud AI is kind of this landing spot, this portal where you can get the Cloud AI stuff, where you can get into, you know, what Magenta is doing, where you can see, you know, what kind of research is coming out of the group in a more, you know, more like user-facing side of things, rather than like, you know, if you're like Jeff Dean, like overseeing kind of the research arms and limbs.
Hello there, this is Jared Santo, Managing Editor here at Changelog. The fact that you're listening to this means you are actively investing in your future in this industry. Things move fast, and keeping up is hard work. Help us help you stay relevant by subscribing to Changelog Weekly. We track, log, and contextualize what's happening in software throughout the week and deliver it directly to your inbox on Sunday mornings. Head to changelog.com/weekly to browse the archives, subscribe, and push the easy button on your continuing education. That's all from me. Once again, that's changelog.com/weekly.
So you mentioned AutoML a couple times, or auto machine learning, and I think it would be great if we like jump into a little bit of detail on that, because it's definitely come up a few times on the show. But as we were kind of discussing prior to starting the recording, we haven't really, you know, talked about it in any sort of detail. So I'm wondering if you could just kind of describe AutoML like generally, how it's different than like how people are used to doing ML, maybe, because some people might think, you know, ML is kind of automated in some ways already, in the sense that like, oh, I can get a CSV right, and then I can like go use random forest from scikit-learn and like choose the column that's the labels, right? And it seems like it kind of just happens for me, right?
Yeah.
So how is AutoML kind of different than that, and maybe also like why is it needed in certain scenarios?
Yeah, so I love, like, you know, practical AI, right? Let's be practical. Let's think about how
That would be great.
yeah.
Perfect.
Yeah. I want to be. Let's take this down the practical route. So we have machine learning, we have AI. How does that impact the world? Like, do you how does it affect the everyday person, right? So a lot of people in the U.S. they use smartphones, and so now they're able to, if they're traveling abroad, they could take a picture of a menu and get that translated on the spot. Or they don't even have to take a picture. Like just within the computer screen, they can translate from like Spanish to English. And a lot of this image recognition or language understanding comes from advanced machine learning. So on the user side, there's already a lot of people using it. And what they found is that a lot of these tools are useful, like if you want to be able to use voice commands. You don't need to necessarily retrain like I don't even know how much data they used, but like all the data that they required to kind of train that voice model, that voice speech to text model, they don't need to necessarily have to go through like every company that needs that doesn't need to go through and do that again and again, right? So Google, having worked on this technology and using it in its own products, makes this available for people. So you can come in, you have an app that you want to build, you want to use you want it to be voice activated, or you want to be able to take images and figure out if they are kid-friendly images. Like there are these models that Google has pre-trained and that they work, and Google is ensuring that these models work well. So without any data, with just the desire to have this feature, you can already plug and play certain products that Google have in machine learning, right? Anything with a lot of stuff, it requires anything that requires vision or audio processing or natural language. I think these are very common use cases. And then on the other end of things, right? Like you were mentioning, you could set up your own Python environment. You could be coding in TensorFlow. You could train your own model. You could feature engineer on your own. You can hyperparameter on your own. You can look at the models and the precision and recall and assess how good these models are doing, and then you can do it all over again. And as maybe you have something running in production, you can kind of have all of that, like all the control over every aspect of that. So that would be the other end. And of course, enterprise cloud technologies, they provide the environments. You have Docker containers, you have virtual machines that can also satisfy that need. What AutoML does is it focuses on the middle piece, or at least trying to figure out how you go from one end to the other. So on one end, you have pre-trained APIs where you have like basically no control over how that model is making decisions. And then you have like build it from scratch, like do it all yourself. For a lot of businesses, it's kind of hard to go sometimes from research directly to, production. And so trying to find that middle point, is what people working in auto machine learning are trying to figure out, like things like hyperparameter tuning, right? Are we tuning these weights around to kind of get a feel? And people before have said, this is a highly intuitive thing where you kind of get a sense of, whether this number should be bigger or lower. Auto machine learning, one of the aspects is like try to figure out how to just simply do that. With the tools that we have now, like it could just be a matter of thinking, why, you might be able to figure out, safe search or kid-friendly images is something that pretty universal for the most part, but maybe not for every culture, right? You might want to label your own data as like, this image isn't safe. Maybe like it's not enough to know which pictures have cats in them. Like you can go to your Google Photos right now and do that, right? You can go into your Google Photos, type in cat pictures, get all the cat pictures. But what if you want to know what type of cat? Or what if you want to know like, different colors of cats? There's specificity that these pre-trained, more general use cases may not provide. And so AutoML in the most like general use case is basically giving you the opportunity to label your own data and then feed that in. So you're getting customization without having to build everything up from scratch.
Yeah. So am I correct in saying that kind of AutoML encompasses what could be a lot of things? So there's also like all this other sort of jargon that we're running across, right? Like meta learning, like learning to learn. And then there's like the transfer learning side of things, which is taking like, pre-trained models and, either fine tuning on additional small amount of data, or maybe adding layers to a network or something like that. So is AutoML kind of an encompassing term that encompasses a lot of those things, or is it more specific or separate from those things?
Yeah, as we know in like AI and ML, jargon is like often it's very controversial sometimes. No, I would say so. Like the people who are like, learning to learn, like these are all groups that for which AutoML is the product. Like they draw upon the findings, and the answer isn't like how do we make machine learning better, which is a research question. What it's really doing is it's trying to figure out how do we deliver the best prediction model. And so maybe that prediction model is like heavily rules based, and they basically figured out in like 2 if statements you can like figure out like the best prediction for a certain problem, right? I think AutoML, like the goal really is to make sure that you're providing the most accurate results given the data and the kind of outcomes that you're looking for.
Yeah, so it's kind of a general term that I guess could encompass many different things. So it could, like you were mentioning hyperparameters, right? Like there could be this sort of automated way of determining hyperparameters. I know there's like maybe more complicated things like figuring out like the right types of, nodes or architecture of your neural network and that sort of thing. So I guess all of that would fit into AutoML. Would that be appropriate to say, I guess?
Absolutely. Like there's this researcher on Google Brain that works like who I'm friends with, and so we joke a lot. And he's always like, we joke that he like uses up like so much of the computing for the whole company. Like he like there's like a leaderboard for like who uses the most computing for throughout all of Google. And one thing that I always joke about, I'm like, oh yeah, like how are those hyperparameters doing? Because it's kind of I'm kind of like minimalizing the kind of work that he's doing by joking about that. But I think it's hyperparameters tuning is just such a fundamental, like something that people who get their introduction to ML like know about, and they know that this is this thing that's been highly, human intuited practice. And so it's kind of this go-to, how would you automate machine learning type deal. But no, whenever I joke about it, he's just like, it's not, I don't mean to, I only do it in jest to minimalize it a little bit. But no, it's a very like common example to use. But yeah, like you said, it's like way more than that. It's what kind of algorithm are you doing? What kind of model are you training? What kind of approach are you like even within like RNNs, there's already so many different ways of like applying and using and deploying RNNs, things like that.
And that almost takes right into what I was kind of had at the top of my mind anyway, and that is, how is AutoML being used in production, and what makes it important for the future of AI and ML? So, if people are using it in some way out in the real world, where is that going to lead for them? Where is that going to take them?
No, that's a good question. I was actually talking to one of the gaming partners, so like a gaming company, and it's interesting because on one hand you think, AutoML's trying to take a lot of that in between the statistical work out of it, right? So I was talking to data science teams, and I ultimately feel like AutoML's like purpose should really be able to be able to extend the data scientists' abilities and intuitions. It give them a sense of like which features are the most relevant, things like that. And sometimes I feel like a lot of this, there's like ML engineers, there's data scientists, they work together, and sometimes they're working separate. But I do think that like ultimately it's the data scientist that's kind of serving that AutoML role, especially for specifically structured data. So we're talking about tabular, spreadsheet-like data. I feel like a lot of that work is the human intuition has been coming from data scientists at large. And the question is, does AutoML meet the standard of the data scientist? Does it extend the capability of the data scientist? Does it give the data scientist who has been this expert, like stewarding this area, does it give the data scientist ability to kind of do more, or to get a better sense of like, what direction should we go in making these decisions? So yeah, so I think that when we talk about these problems, we think like, if you're a gaming company and you're looking at use cases for whether a player is going to continue, like whether a player is kind of, plateauing and really like the game is just not engaging anymore, and at what point that is, and you're trying to make a prediction that after these actions, this next thing's happening. How do you correct course so that you make something that is more satisfying to the user? Things like that, where like I think a data scientist would sit and kind of go through like, here are the signals and here are the science. I think AutoML would be like an additional like tool to be able to help arrive at those conclusions in a more efficient way.
So there is like, I guess, some level of expertise that's needed to use AutoML. Like I was looking at one of the, I'm not sure where I was seeing this. I think this is one of the examples when I was looking at AutoML on the Google Cloud site. But, my life right now, at least, is all about AI and natural language. And I think I was seeing, one of the examples or use cases they were talking about was like, oh, you have this machine translation model, maybe that's pre-trained for some language pair, like English to German or whatever. But really you need like some very specific types of vocabulary translated. Like maybe it's like legal vocabulary, or maybe it's like some domain that's not covered well by the data that the model was trained on. So you need to kind of get that model, fine-tuned a bit to that vocabulary that's not sort of general vocabulary. So I'm assuming that still like, to structure that data, to get it in like the language pairs that you need it in, to kind of understand and evaluate if your model's like doing well, even if you're not like setting all of the hyperparameters, or you're not like, coding all of the neural network architecture, there's still like a level of expertise that's required to set up that experiment, right? And be able to know if it's working. Is that right?
So I would say that we were talking about tabular data earlier, right? I can kind of walk through a little bit of like how that would look. But I would say, to answer your question, that you really need to, I think the expertise really comes in once the model is trained, because from that you need to have kind of a sense of whether the model is doing well enough for you. So for every in production, every feature, every use case is going to be different. And sometimes, if you're 99% accurate, that's good. So for some of them, that's not good enough, right? But really, I would say the expertise comes in with also if say the model needs to be better, or say some change needs to be made, to be able to understand like how to engineer or shape the data in a way that's going to give you a better outcome. So there's two different ends of it, right? You could just trial and error it, give it data, run the prediction, or train it and then run the predictions and then see how well it does. And if it's good enough from your sense, I would say that that's kind of the bare minimum. But I think, to hold to kind of higher standards and to kind of oversee like, what I've said earlier, the state of the art is doing. I do think it's important to have somebody with like data science or statistical understanding or machine learning understanding to be able to see whether, like, to kind of just not let it run in the wild. And this is something that that people talk about, AutoML. This is like true democratization, because you're really just giving, all you have to do is just have the label data, show it lots of examples, and then it's going to make the prediction. I've talked to like, the product manager or the product side of TensorFlow, going back to the research side. And what they would sometimes say is that truly democratization? Because at the end of the day, you're relying on Google Cloud AutoML tables to make this decision, and you're controlling these two ends. You get to decide what data goes in, and you get to decide whether this prediction model goes into production. But like, arguably TensorFlow, this open source tool for machine learning, you actually is like ultimately giving you all the control and all the power. It's just the learning curve is much higher. So there's the cost benefit of that. But yeah, I would say that I could teach, a 13-year-old how to use, with no machine learning understanding, somebody who's like, understands how to point and click and load in files, how to train their own model and give them kind of an intuition of what that evaluation, how that should evaluate and how to test that out.
So one of the things I'm wondering, I'm pretty interested, I know in a few minutes I'm going to ask you to kind of take us through kind of an example, if you would. But before we get to there, what are some of the disadvantages maybe for AutoML? Things like would interpretability be one of those? And are there certain kinds of domains for which it might not be the most suitable thing? And I guess since I'm talking about what is it potentially not best suited for, what are some of the biggest research areas, the biggest open questions that you guys are taking AutoML into? So what's it challenged on, and where do you see it going in the future in terms of applicability?
Yeah. I guess in the spirit of AI, it's like I'll throw out more buzzwords like humans in the loop and mixed initiative, co-creative systems,
differential privacy.
Yeah. So I think the question I get asked most when I'm working with like data scientists or showing teams, customers, partners, people who want to. People who are already or want to use machine learning, when I show them these tools, you get kind of a range of questions. If somebody is like more on the data science, machine learning side, they'll say things like, what if I want to be able to get in there and like make some changes? I mean, it gives you like this tool, and honestly, this tool changed. It launched AutoML tables for tabular data, launched in April of this year. So it's changed a lot already since then. It's not been that long, so it's constantly changing. But right now, what is available to you is you can once the model is trained, you can call a REST API. You can export the model as a TensorFlow package and download it onto your own machine and run it from there. There's things like that you can do, right? But what we get asked often is like, well, can you give us more information? We want more analytics. We want more, we want to see like really, how well the features are doing in more detail. And that is like totally under the hood. You don't have access to that. You can't, say if you wanted to, you couldn't really tune the hyperparameters in this case. It's really just giving you the endpoints of machine learning from training to inference. So I would say that that's probably one of the drawbacks, is that you're ultimately not getting the amount of control that you would if you were building your own model from scratch. And that question of control, or at least intuition, and you said interpretability and understanding why it's making these decisions, it's even more abstract. It's it's almost like by design is trying to like reduce complexity by not showing you these things. But again, with this concept of humans in the loop, or understanding what kind of controls do we want, the whole point of machine learning, and it is almost like seen in research as the more humans are involved, the more they're going to mess it up. But as we reintroduce working in the team Magenta, right? It was focused on, Project Magenta was focused on creating generative tools, like extensions of humans. And so this concept of what kind of control the human wants is very important. The problem is that machine learning can get very complicated very quickly. So either people are just overwhelmed with the burden of choice that they have and not really understanding how it all works together, or it's like we're kind of taking that away so that they can still make decisions without kind of taking for granted all the stuff that happens in between. If that makes sense.
Hey, guess what? Brain Science is officially launched. Episode number 1 is on the feed right now, so head to changelog.com/brainscience to listen, to subscribe, and to join us on this journey of exploring the human mind. Once again, changelog.com/brainscience, or search for Brain Science in your favorite podcast app.
Okay, so let's say, so I've never used AutoML other than just kind of browsing around the website and looking at some examples and that sort of thing in very general detail. So I was wondering if you could kind of just walk us through, like if I'm going to go implement my first AutoML application or workflow, what are kind of the steps I go through, at least with, Google's AutoML tools?
Yeah, of course. And yeah, Google's not the only company that's offering these capabilities, but yeah, it definitely starts with what you've been saying earlier about how you have certain language, like say you're a German doctor and you need a tool that recognizes that context, or you're, searching for cat and food pictures is general, but maybe you're an automotive manufacturer and you have all this labeled data of car parts that isn't going to show up in the more, general use cases of the pre-trained models. So what you need to do is you have this data set and this data set is good and accurate. What you would do, and in this case, let's use I've talked a lot about tabular data, right? So we're using spreadsheet data. Spreadsheet is something that, almost everybody uses today. But in this case, what feature we're looking to establish within a spreadsheet is the ability to say, select a column in a spreadsheet and say, given all these other columns, can you predict this, what the value of this column is going to be? And so let's say it's it could be categorical, it could be numerical. The example that I've been using a lot is there's, one of the open data sets that we have is a banking data set that shows different types of banking customers and what they things from, how often they deposit to what their income is to what kind of jobs they have. And then trying to infer which banking customer is most likely to have to turn on direct deposit. So they're going to have their paychecks directly go to the bank. And so what you would do is you would find, first of all, whether we talked about CSV files. Of course, this is Google, so you could have your data in BigQuery, and you just give it the BigQuery ID. You go to AutoML tables, and you would load in that data set. So you would import it, and given all the different, so it'll be labeled. It'll be either categories or numbers or text. And from there, you have the opportunity to kind of look at the different column names. From the column names, you can then, nullify or select your features. In this case, they have things like age, education, balance, housing, loans, things like that. And from there, you look at each of the column types and you select one to be the target. In this case, we're going to select direct deposit. So this is a true false. Does this person use direct deposit? Do they not? Then there's other analytics you can look at, right? So it gives you an opportunity to see kind of the spread or whether there's any features or any columns that have missing values or invalid values, things like that, where you can kind of remove. And this is where a data scientist said that, these kinds of tools actually are very useful because they often have data. They have lines and lines and lines and lines of data for which some of the data might not even be valid. So being able to detect that automatically would be very useful for them. From that point on, you would just then train the model, and the selection you'd make there is how long you feel like training for. So you could say, I want to train usually 1 hour, honestly, for maybe these are approximations and it changes case by case. But an example, right? For this case, I would say for 4,000 lines of input, you could train for an hour and you'll get a decent result. You'll get 95% accuracy for predicting whether or not someone has direct deposit. Once it's trained, you select that threshold. If it finishes earlier, and of course it's going to detect things like overfitting when it's just kind of reaching diminishing returns. So it will terminate early as well if it needs to. But you get at the end of that, you get an evaluation. So you look at, there's the recall, there's precision, there's looking at the true positive rates and the false positive rates. There's the accuracy. So in this case, this model that I'm just going to pull up one right now, this model has accuracy of 91%, which is, pretty good. Again, case by case. It's what is your use case? What is your threshold in production? And it's going to differ. It'll also show you feature importance, how the labels are doing. And you can then basically, you could deploy it right then and there. You can just deploy it within AutoML, and then it's, you can run online predictions, you can run batch predictions, or you can export the model. So you can, like I said earlier, export it. It'll be a TensorFlow package. You can run the model in a Docker container. You could take that Docker container. You can download it onto your local machine. Or you can just, not do any of that and just use REST API and be able to make predictions that way. And so that kind of gives you kind of the end-to-end, it's basically once you load it in and you click train and the training completes, you're basically ready to, and you have to deploy it as well, but you're ready for online predictions after those few steps.
So just to clarify, to make sure, I know like Daniel and I have come at things from more of a framework perspective and using TensorFlow or PyTorch or one of the other frameworks over time. In this case that you're talking about, you're really not doing that at all, right? Your AutoML is its own process, and you're selecting the data from BigQuery or elsewhere, pulling it in, and essentially producing a product at the end as in the form of a model that you can go use. Is that fair, that it is a parallel path versus an integrated path with whatever framework you're using?
Absolutely. Yeah. You're loading in the data, you click a button, it says train, and then an hour later you have this model which you kind of look at the stats for it, and then you're online after it's deployed. So it's like a few clicks. I mean, getting the data is non-trivial, I would say. And then making sure that the model is actually performing the way you want it to is also non-trivial. But yeah, it is like a few clicks away. And then you have what you would normally do if you had you had like maybe even like a TensorFlow notebook, right? You would still have to you still had the ability to choose the type of approach you want to use and then, change the values around a little bit. But in this case, you don't really have that. You get to select the target of which you want to be what you're predicting for. But that's about it.
Yeah, I definitely see what you're saying about like the expertise that's needed, because like if you're looking at a screen and you're getting, first of all, like a package out or a Docker container out, there, like you need to understand how to work with those things, or like REST API. So there's like engineering expertise there, of course. But even if you're presented with the screen and it says like, oh, here's precision and recall and these different things, like, there has to be a level of understanding of those things to be able to understand, if your model is really doing what you want it to do, like you said. It seems like there's like, if I'm thinking about my AI workflow or machine learning workflow, there's of course always the data side of things, which is still going to be in some cases hard, like you're saying here, because like, the data quality is going to influence things. There's the training process, which, if you do it manually, might involve, like you were saying, hyperparameter tuning, like trying out a bunch of different architectures or models and that sort of thing to where you get something that works. Then you have to, evaluate that and then put it into production. It seems like here you're really greasing the wheels around that training process side of things, where you don't have to think as much about the architecture, the specific model, the hyperparameters. And then you're also helping a bit in terms of like, of course, like productionizing that in the sense of making a REST API available and that sort of thing. So you can spend a lot more time thinking about the data and the type of model that you want out, rather than those sorts of architectures and other things.
Yeah, that's totally it. That's the idea, is to make that more accessible, to give people the opportunity to kind of use it at that level of abstraction. But like, I think in some point we're trying to look at like, the full sense of like how much control and what kind of control we want to have in as we create these models as well.
Cool. Yeah. So to kind of wrap up here, I think this has been great I mean, I've learned a lot going through this.
Me too.
And definitely want to like try out some of these things. So I guess ending, to kind of end up with some useful things, I was wondering if you could just kind of recommend, like, so thinking about someone that's maybe wanting to try out these sorts of AutoML techniques, what the kind of easiest way for them to try out those things are. Maybe there's tutorials or like, notebooks, or I don't know what the interface is to try those things. And then also if people are interested in kind of learning generally about like maybe the methods behind AutoML and like working on those, like learning to learn things and automated hyperparameter tuning, if there's any kind of specific places that you could point them to.
So yeah, for people who want to know about like AutoML in general, I mean, the Google AI the portal. They link to one of the groups. One of the researchers that I hear a lot of working in this area is Kwok Lei. He's a Google Brain research scientist that has a team of people working in auto machine learning. So anything under him, any of his publications, I think would give you kind of an understanding of the state of the art within that area. For people who want to try it out, so if you go to cloud.google.com/AutoML, it'll kind of bring you to, all things AutoML that is available as tools for people to use. It gives you kind of a list of the different applications or verticals. There's site where you have AutoML Vision, AutoML Video Intelligence. So this is, again, you're providing your own labeled data. There's language, so AutoML Natural Language, AutoML Translation, and then structured data, which is what we talked about today, AutoML Tables. There's a few customer testimonies where you can see how it's being used, and a little bit of a description. And then you'll find if you go to structured data, there's a video narrated by me. I pulled together this video for explaining kind of the basics of it. But if you want to try it, again, you would choose from those categories. And so if you choose, AutoML tables, there'll be the opportunity. It'll kind of pull up the UI in the cloud console. So of course you'll have to have a Google Cloud Platform account. But you do get some. You could train for free for up to a certain amount to kind of try it out for yourself. And then actually the cost isn't very much. I'm not on the sales side, so I actually don't know the exact numbers. But every time I've talked to a solutions engineer and heard them quote, it's very low amounts of money once you actually want to get it going. But yeah, I do know that there's amount that you get to use for free. So if you just want to check it out, try it out yourself, it's pretty accessible. And even if not that, if you want to even, try some of the pre-trained APIs, you want to upload a cat picture and see if it knows your cat is a cat, you can just do that within the web. So if you just want to see how well these pre-trained ones work, they have online demos within the website as well.
Awesome. Well, thanks for pointing those things out. We'll definitely share those in the show links. So make sure and check out the show links. We'll put those links there, and you can try out AutoML. And definitely consider joining our community somehow. So you can go to changelog.com/community, and we have a Slack team where you can chat about AutoML and practical AI and all those things. We also are active on Twitter and LinkedIn, so make sure you engage with us. Tell us what you're using AutoML for, or where you found it useful, or what research you're interested in. But thank you so much, Sherol, for joining us. Really great conversation. It was really great to hear your story, hear about some of the things you're doing and the things Google is doing in AutoML. So thank you for taking time.
Thanks a lot.
Yeah, thank you.
All right, thank you for tuning into this episode of Practical AI. If you enjoyed the show, do us a favor, go on iTunes, give us a rating, go in your podcast app and favorite it. If you are on Twitter or a social network, share a link with a friend. Whatever you got to do, share the show with a friend if you enjoyed it. And bandwidth for Changelog is provided by Fastly. Learn more at Fastly.com. And we catch our errors before our users do here at Changelog because of Rollbar. Check them out at rollbar.com/changelog. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out. Support this show. This episode is hosted by Daniel Whitenack and Chris Benson. The music is by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. When you go there, pop in your email address. Get our weekly email keeping you up to date with the news and podcasts for developers in your inbox every single week. Thanks for tuning in. We'll see you next week.